Hello there, my name is Birdie. Thank you for watching the first video and, subsequently, the first series which I'll be posting on this channel. This series will be a Down to Basics crash course over Unity and C#, which is aimed towards absolute beginners in programming. In the span of this series, I'll be teaching you the basics of using C# and Unity to create a simple game, shown in the background now. This series will include the following concepts: character movement, collectible collection, user interface change, and wind goals. So with the assumption that you've already downloaded Unity, the game creation software, and Visual Studio, the program which we'll be using to write our code, both downloads will be in the description, enter into Unity Hub and press New Project, and then this will direct us to a bunch of templates that we can use. For this tutorial, we'll be using 3D. So make sure that it's selected, and then come down here to project name, and you can name it whatever you want. And then come over to here, location, and you can create your own file, which will have all your Unity projects in it. And then from here, you can create a new folder, call it whatever you want again, and then press select folder. And then from there, once you got your folder selected, you can press create project. And now this will take a little while to load, so let's be a little patient. Once it has finished loading, you'll see a screen similar to mine. First things first, we'll need a ground for our character to stand on. So bring your mouse over to the empty space in the hierarchy, right click, hover over 3D object, and press plane. So this will be the ground that our player will be standing on. And to make sure that we have enough room, we're going to scale it up to 100 and the X axis and 100 and the Z axis. And we'll rename this to be ground. A few other ways which you can rename it is by double clicking the name, which I can be lucky enough to get working right now, or just right clicking and click rename. So now that we've got our ground, we'll need our player. So let's right click again, hover over 3D object, and then click cube. So this will be our player for the game. And because we're very far zoomed out, it might be a little hard to see. So let's double click on cube, and it'll take us all the way up there, close up. So now we'll name this cube player, and because it is a little submerged into our ground, we can bring it up by setting its position to be 0.5. And now our player is a little hard to differentiate from our ground, so let's create a material to change its color. To do this, first we'll come down here to assets, right click, go back to create, and create a folder. Now we're going to call this folder materials. Let's enter into this folder, right click again, go back to create, and this time click on material. We'll call this material player and change the color. Now you can choose whatever color that you would like, but for this tutorial I'm going to be choosing a dark blue. Now once you have your material color chosen, you can click and drag it over on top of the player, and it'll set your player to be that color. And also, if you come over to the inspector panel of your player, you can see right here that the player material has been added to it. So now that we've done that, let's have the main camera be a child of the player. To do that, we're going to click main camera in the hierarchy and drag it onto player. Now the reason why we'll do this is because making a game object the child of another game object allows that game, the child of the game object, to move wherever the parent goes. For example, whenever you were to move the cube, you can see that the camera moves along with it. Same thing with rotation. Rotating it causes the camera to move as well. So now let's go back and reset the position of that by coming up to here to transform, pressing the 3 dots and hitting reset. And then let's bring our cube back up to 0.5. So now, as you saw at the beginning of this video, the camera was positioned above the player. To do that, we're going to come to main camera, reset the position again. So now that it's aligned with the center of the cube, we can bring its y coordinate up to 7. And now it has gone above the cube. And to angle it downwards, we'll come to rotation and set the x value to be 90. And there we are. The camera is positioned properly above the cube for this game. So now we're going to come back to this cube, come to add component, type in rigid body, and select the one without 2D. So now the rigid body component basically allows our game object, in this instance our player cube, to have physics such as gravity and drag. And it also allows collision detection. So now that our cube has a rigid body, we can start our scripting. So to do that, let's come back over here to Assets, right click, and create a new folder and name it to be Scripts. Enter into this folder, right click again, go back to Create, and we can press C# Script. And now let's name this script Player Movement. And it'll take a few seconds to compile, and then we'll be able to open it. So what's nice with Visual Studio and Unity is that it will automatically have a start and update function ready for us. Most people you'll see will just automatically delete it, but we can just leave them off to the side for now, and I'll explain how they work later. We're going to first start on our variables for this script. So come up here, press enter a few times to give us some space, and we're going to start with some float variables. So to create some variables, we're going to type in public to make it a public variable, float, and then name it HORZ, axis, and then do a semicolon. And we're going to do this same kind of variable, except it's going to be called vert, axis, semicolon. So I'll explain more about it later, but both of these float variables will be holding a value that determines the direction which our player will be moving. So let's write another float variable, public float, except this time it'll be our move speed. And that will basically be the speed at which our player moves. And now we'll need one more float variable, except this time it'll be friction, which of course will be determining how much drag that our player will get when moving. So now we're going to need a different kind of variable, which is called a vector3 variable, and we're going to be calling it move direction. Again, I'll explain these types of variables in just a second. The final variable that we'll need is a rigid body variable, and we're going to call it RB for short. So now we have all of our variables complete, and let's explain what they do. So these 4 float variables all do pretty much the same thing. Generally, in C# and every other programming language, there are 3 main ways to store text and numbers. These are with strings, integers, and float variables. The difference between the 3 is quite simple. String variables are considered lines of text and can hold letters, numbers, symbols, and spaces. Integers and float variables, however, are numbers and can be used for math and other purposes, unlike the string variable. With the difference between a float and integer variable, the integer variables can only be whole numbers, unlike the float variables, which can be whole numbers and decimal numbers. So this is why we'll be using a float for these 4 variables. Now, for the vector3 variable. A vector3 variable is basically a variable which contains an x, y, and z value at the exact same time. And we'll be using this variable to determine what position and way in which our character will be moving. And now we have the rigid body variable, which we'll be using to edit our rigid body of our player without having to call it every single time. You'll see what I mean in just a few seconds. So let's start with our code. But first, I'm going to explain what the start and update functions do. So the start function is called at the beginning of the game whenever the script is first called. And it is only called once, as you can see here in this comment. The update function, however, is called once per frame for every frame that is loaded onto the computer. For the start function, we can start typing our code. So we're going to type in RB get component, these angled brackets, rigid body, parentheses, semicolon. This line of code causes our rigid body variable to align to the rigid body of whatever this script is applied to. The next line of code we'll have in our start function is rb.freezeRotation equals true. This will allow it so that the rotation of our cube is not affected by our rigid body. Now, after this, we're going to need to create a function to collect our horizontal and vertical axis input. To do this, we're going to type in public void and then call this function game input parentheses curly brackets enter. So with that, we have created a function and it automatically should give us space to write in code. And here we're going to put in horizontal axis equals input dot get axis raw parentheses quotation marks horizontal. Alright, then semicolon. Now we can take this line of code and to make our lives easier, paste underneath it, but instead change the variable to vert axis and then change horizontal to vertical. Now these 2 lines of code grab if our input is being used for the horizontal axis and vertical axis. If that doesn't make any sense, let me explain it better. If we come back to Unity and let this script compile, we can come up here to Project Settings, and come into Input Manager, and look in Horizontal and Vertical. And we'll see that the buttons AD and SW are set up for horizontal and vertical, for positive and negative. So whenever those buttons are pressed, and this code runs at the same time, it'll pick up that those buttons are pressed and set them to be on the horizontal axis variable or vertical axis variable. So let's say W is pressed. If W is pressed, it'll set positive for the horizontal axis, which means it'll set horizontal axis to be equal to 1. However, if S were to be pressed, then it would set horizontal axis to be -1. And if neither W nor S is pressed, horizontal axis variable will be 0. And the same is true for vertical axis, except with A and D. So now, after that, we're going to come into our update function. And we're going to call that function by typing in the name of the function, parentheses, and then a semicolon. That ensures that the game input function is called on every single frame. Now, after that, we're going to type in rb-drag equals friction. So now, for whatever friction that we set it to, the RB, the rigid body, drag will be equal to that. And that is pretty much right here in our player. So we'll go to player, go back to inspector, and in rigid body, we see our angular drag and our regular drag. The drag will be set to whatever friction we set with that line of code. So now, after that, we're going to need 2 more functions to be able to make our player move. The first one we're going to have to create. So once again, we're going to type in public void, and this time we'll name it move player, parentheses, curly brackets, enter. So now, inside of this function, we're going to have 2 lines of code. The first one is move direction equals transform dot forward times vertaxis plus transform dot right times horizaxis, semicolon. Now, what this line of code does is takes the x, y, and z of move direction and sets it for vertical, which is the x coordinate, and if it's +1 or -1, it'll set it to there in move direction, or if it's 0, of course, it'll set it to be 0, which means that we're not moving in on the x coordinate. And for the horizontal coordinate, will be moving if W or S happen to be pressed. So if one of those is pressed, it'll either be 1 or -1 or 0 if neither is pressed, and that'll be moved to the Z coordinate of move direction. So that is what this line of code intends to do. It'll basically be saying in move direction what position we'll be moving. And now after that, we actually need the line of code to make our character move. So we're going to type in rb.add force parentheses move direction times move speed times 10f comma force mode dot force semicolon. So in this line of code, we're adding force to the rigid body of our player in the x, y, and z direction multiplied by our move speed multiplied by 10f to get it to move a little bit faster. The reason why we have f here is because move speed is a float and we can't multiply a float by an integer So we have to declare that 10 is a float by typing F here. Force mode is required after add force, and we use force here because it adds a continuous force to the rigid body instead of any other kind of force. So now after that, we need a way to call this function. And by doing that, we're going to add in our final function for here, which is public void fixed update, parentheses, curly brackets, enter. And now in here, as we did last time, we're going to type in the name of our function, parentheses, semicolon, to call that function. And with that, we have got our movement script completed. So let's save all that by pressing Control S, minimize Visual Studio, come back into Unity here. All right, so we can go to our script, go into our player, and click and drag our script into the inspector menu for our player. And as you can see, it'll attach that script to our player. And now from here, we'll be able to view all of our variables that we've added, and we can also edit them as well. So we'll set move speed to be 14 and friction to be 15. We'll also come over to here to rigid body, press this little circle here, and select player. And now that'll set the rigid body in our script to the rigid body of our player. So now our little cube here is now able to move. However, you probably can't tell very well. So I have a little challenge for you. I ended the video challenge. I would like you to add a cube that is a different color to our player cube and put it somewhere on the ground by our player cube so we can see that we're able to move. Alright, you can pause the video here to begin that challenge. Alright, the way that we'll go about doing this is right-clicking here in Hierarchy, 3D Object, Cube. We'll reset the position of it, then set its Y to be 0.5, and drag it somewhere away from the cube. Alright, then we'll go back to Assets, Materials, right-click, go to Create, Material, and I'll just call it Roll for now. And then come up here to Albedo, and set it to whatever color you like, and then drag it onto this cube. And now we're able to see that our cube is able to move without the white background here to make it look a little unimaginary. Alright, so with that being said, this concludes the first tutorial. Thank you all very much for watching, and I hope that you'll continue on to the next episode. If you like this kind of content, please don't forget to like this video and give me any suggestions for any other kind of tutorial that you'd like to see. Up next, we'll be building the maze and creating collectibles that we can pick up. Alright, I hope to see you all there. Once again, thank you for watching, and goodbye.